Hey there, we're going to do a short little chapter on set theory, just the basics. We're going to look at some ways to count things, how sets fit together, what's in a set, what's not a set, and all the notations that we use. This will help us in our probability basics section that we're going to do following. So, make sure you do read in pages 77 to 90 in the textbook. That will be helpful for you. Do that first, as usual. So the basics of this is a set is just a collection of distinct objects. They're called elements. We can define by describing, or just saying in words, listing the elements of the set in braces that are curly brackets. So here's just a way to describe sets, the set of all even numbers. That's one way to just say that in words. The set of all books written about travel to Chile, that's another way of just saying it in words. But sometimes we want to list things out, like these. Sometimes just writing words. A lot of times it's numbers, like you've probably heard of the set of all real numbers and such like that. So now the next section here. Okay, so now we're going to take a quick look at page 30. This symbol here means is an element of these braces. With an empty space, it's just the empty set. We could also write it with a circle with a line going through. That's why it's important to write your zeros just as a regular zero, not with a line through. Sometimes people use computer symbols that want to write the zero with a line through, but that is a little bit different. It doesn't extend outside the circle. So you do need to be real clear on that. Sometimes that's called the null set also. So here we have set A is A, B, C, D, E, F. List the elements and use this symbol here to denote element of. I'm just going to do one or two here. A is an element of set A. B is an element of set A. You could just list them out like this. A, B, C, D, E, F are all elements of set A. And usually we use capitals for the set and smalls for the element. So a subset is when the other set contains only elements from that particular set, but it may not contain all of the elements. Sometimes it does. If B is a subset of A, we write B in this like sort of sideways U there with a line under it is a subset of A. A proper subset that is not exactly the same to the original, we would write it without the line. So it's kind of like less than rather than less than or equal to, if you think of it that way. Example 3.4, we have let A equal this set 1, 3, and 5. Set A might be a subset of what larger set? Well, we could just throw another number in there and have it be a subset. We could say maybe the set of all odd numbers. That might be something. There could be a variety. Now we're going to look at page 31, union, intersection, and complement. So the union is what is in both entire sets. Sometimes there's just two sets, sometimes there's more. We have this, it looks like a U, it's not actually a U. X is an element of A union B if X is an element of A or X is an element of B or both. In math, or really means and or. It's in both entire sets. We want to count the intersection where they have a shared element or common element, but we only want to count it once. We'll see that later when we do cardinality and looking at counts. So let's take a look at example 3.5. We have, so this one I'll do out for you, and then you can try some others. We have set A equals orange, yellow, red. Set B is orange, brown, purple. And set C is pink, brown, red, yellow, orange, purple. So if we want to find A union B, so I'll do A union B, and you can do for classwork, just pause the video and do B union C and see how you turned out. So A union B, I just want everything in both entire sets. So I have orange. So usually I just write what's in that first one, yellow, and then red. And now I know I also want everything in B, but if it's already there, if I already wrote it, I don't write it again. So orange I already have. Brown isn't there, so I need to write that one. And purple. And that's really all there is to it. That's a union. And this is where it's shared. You have to have it there, but only once. Now go ahead and try this one. When you're writing sets, make sure you do put the brace there on either end so that we know it's a set. Okay, so there's your answer for this classwork. I'm probably not going to put this on the listed key because you're working right along with me. Orange, brown, purple, pink, red, yellow. Intersection of two sets contains only the elements that are in both sets. So it's common to both, like we talked about before with the orange. The intersection is notated A intersect B. So that's and is the word we use. It's an upside down U or horseshoe shape. X is an element of A intersect B if X is an element of A and X is an element of B. So that's the key word there is and as opposed to or. So again, let's look at an example, and I will do one as an example and you'll do the other one as a classwork. So I'm going to do A intersect C. So we're just looking at A and C. So make sure you do zero in on which set they're asking you about. So orange, I have to look down here. Is it there in C? Yes. So I'm going to put orange. Then yellow. That's in there. And also red is. So that's actually a subset as well. Now go ahead and try B intersect C on your own. Pause the video. Okay, so here's the answer, orange, brown, and purple. So now we're going to take a look at page 32. Complements. Complements just mean what's not in that set. So there's a couple of different ways that you may write that. We often use A with a little superscript of C above it or a little tick mark. Sometimes we use this symbol. It's called a tilde. This is an apostrophe. So in order to write this, we want to kind of condense down our set. So we have B complement intersect C. So usually we're comparing it to some kind of universal set, which we'll see later, that we've defined, or we're intersecting it with another set. Otherwise we would have so many elements in the set, we wouldn't know how to narrow it down. That could get complicated for our complement. So here I'm going to do B complement intersect C. So what this is saying is I want to write the elements of C that are not in B. So I just have to look here now. Pink, that one's okay to write because it's not in B up here. So I've got pink, brown is in B, so I don't want anything from B, so I'm not going to write that. Red, I can write. Yellow is okay. Orange is not okay, so I'm not going to write that. And purple is not okay because that is in the set here. So I'm done there. And I close that out. So I'll do that one as an example. And again, classwork, just do it really quick. You're going to do the next one here, A, intersect B complement. So you're going to write down what's in A only. So you could kind of look at this as A only. I don't want anything in B. I'm not worried about C though at this point. That's why we use this notation of intersection. So pause the video and go ahead and do that one real quick. Okay, so here's the answer for that. The set of yellow and red here. So this is the note I was talking about before. This is also in your book in more detail, but since everything from the color fuchsia to puppies and peanut butter are included in the complement of a set, so it wouldn't even be limited to colors, we need to put some parameters around that. So that's why we're doing the intersection of a specific set. The universal set is a set that contains all the elements, including itself, usually denoted by a capital U. The elements in the universal set is defined by the context of the given set or sets. Okay, so we're going to push up to example 3.8. So a variety of things here. A set of books. We could say maybe all books in the library, all books in the bookstore. We could say all books in Orca Books downtown Olympia. A set of friends on a social media site. I think your book uses Facebook. We could say my friends on Instagram. And you get the idea here, but we're just describing out a set of numbers. I could say all integers, or I could kind of write out like this. If I wanted to write the integers out numerically, use these little dots to show that the pattern continues. So now we're on page 33 of your workbook. The complement of any set is relative to its universal set. Hence, a complement contains all elements of the universal set not in A. So this one I think is pretty straightforward for you to do. I'm going to leave that one as a classwork that you can just go back to right after I do an example. And this one is finding a complement. So we're thinking it's in U, the universal set. But it's not in A. So make sure you know how to write that out. I'm going to do this example, and then you could do this one as classwork below. And then I'll stop this video and make a new one for the Venn diagrams. So here we have example 3.10 or 3.10. Push this over so you can see it all. It's a little cut off. This should be a 20 here on the very end with a brace on my sheet. So we have A, intersect B complement. This means I want A only. None from B. So the easiest way, I think, if you have strings of numbers like this, is just to look at them and say, okay, 2. Is 2 in set B? Yes, so I'm going to put a little dot there. I need to use these numbers again, so I don't really want to cross it out. 5 is okay. It's not in B. 7 is in B. 8 is not. 10 is not. 11, I do see over there in B. 12 is not, 15 is not, 16 is, and 20 is. So all the things that don't have a little circle under them, A intersect B complement. I can put a tick mark or apostrophe, kind of nice. 5, 8, 10, 12, 15, and that is it. And then just double check, none of those are in B, so that's my answer for that particular problem. Now go ahead and go back to 3.9 and do part